by induction is we're trying to prove that this pattern, if you keep adding it up forever, will always equal this. And it's very step by step, and people either like them or hate them. Some people in my 5th hour class said, I didn't think it could get worse than geometry. And then other kids said, oh my gosh, these are so much better than geometry because I am doing the same thing every time. And it's just whichever way you think, if you like it or you don't. But I like it because it's very systematic. Every time, step 1, I'm going to prove that it's true for P sub 1. And I'm going to plug in 1, and I'm going to get 1 over 1 times 1 plus 1, and show that that equals 1 over 1 plus 1. This should always work. This would be 1 over 1 times 2, which is 1/2. This is 1 over 2. It works. So we proved that it works for the first term. The second step is we want to prove that it's true for P sub k plus 1. And again, it's very systematic, but the thing that we got to make sure that we know by Wednesday when we're having our test is you got to be able to do these steps without having a paper to look at an example and know exactly what to write every time. But every time, if I'm going to prove for the k plus 1 term, the first thing I have to do is assume that P sub k is true, which means I have to make a P sub k pattern. And remember, all we do is we change our P sub n to P sub k. So I say that P sub k equals 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus 1 over k times k plus 1 equals k over k plus 1. And again, all I've done is change the n's to k's. We're assuming that that's true. That's kind of important later because we always plug in the sum later on. And this is where I break it up into 2 parts. I always do the end part first. So I always do this and figure out what I'm trying to get. And then I go back and I work with the pattern side. Ideally, it would be lovely to write this all on one line, but I've never been able to fit it. So that's why I break it up into 2 sections. So every time, the first thing I'm going to do is I'm going to do the end result. What would the k plus 1 sum equal? And all I do is replace k with k plus 1. K plus 1 would be k plus 2 there. That's what we need to get when we go back and do that other side. This is our end result. That's kind of the great thing about proof by induction, is every time if you do this, you know what you're trying to get later. And now I always go back over to the other side of my paper and I say, okay, I have this part. Now let's write this sum out and add that next term also and see if we can simplify it. So now I'm going to say, what would that k plus 1 term be in the pattern? So I write the whole pattern again. 1 over 1 times 2 plus 1 over 2 times 3. And I might get a little lazy and leave 1 out. Plus 1 over k times k plus 1. Notice I haven't changed anything. In order to write the k plus 1 pattern, you have to include all the other terms that are before it, right? So we have to include all of this. Then we add our next term. So that's when the difference between p sub k and p sub k plus 1 is now I'm going to add the next term. So this would become 1 over k plus 1.
Where did that come from?
Because I'm adding the next term.
I know, why you put k plus 1?
Because you replace k with k plus 1. And I'll replace this k with k plus 1 also. Here, I'll just write it as k plus 1 plus 1. Every time, to find your next term, you take the k term, and you replace every k with k plus 1. Every time. So you can go back up here, or I guess you could look right next to it. So this k turned to k plus 1, this k turned to k plus 1. And every single time we're trying to add this together. If we did not assume that p sub k was true, we could not finish this proof. But because we said this is true because they gave it to us. We can now go back every single time and we can replace all of this equals P sub k. So every time I can write that as P sub k plus my next term, which is 1 over k plus 1 times k plus 2. In fifth hour, some people ask me, could I just write this step? Do I have to rewrite the whole pattern if I know every time I'm going to replace P sub k? I'm okay with it if you don't. I like to write it because I like to show you where it's coming from. I like to know, for you to know why I'm replacing this. But if you get that every single time P sub k plus 1 is going to equal P sub k plus your next term, if you left this step out, I'm okay with it. Every single time after you replace this, you know what that equals. We assumed it was true. They gave it to us. We know that if you add up the first k terms, it equals this. And that's where in our notes I said circle this and draw a line so you remember where that came from. P sub k equals this. So I can replace P sub k just in terms of k. So I can replace that with k over k plus 1 plus 1 over k plus 1 times k plus 2. Although this one is a little different than the other ones, it had fractions in it, it's the exact same process. The only thing we have left to do is to make those match. Remember that this is supposed to look like this when you're done. This is one fraction. These are two fractions. So that means that we're going to have to add and get a common denominator there in order to make those match, which isn't so bad to do. You just got to remember that when you add fractions, you want to take the common denominator here. I'm going to just write it over like this, which means right now these both have a k plus 1. But I also need a k plus 2 if I was getting a common denominator there. Common denominator, you have to take every factor that's listed. It's called the least common denominator because you want to try to find the smallest denominator. Which means if you see fractions, don't ever multiply out the bottoms before you add them together because your denominator is going to get crazy. But all you got to do to get a common denominator after you find the common denominator is you say, what do I need to do to make this look like this? Well, I'm missing a k plus 2, which means you have to multiply the top and the bottom by k plus 2, and on the top you would get k squared plus 2k. What do I have to do to this to make it look like this? Nothing, which means I have to do nothing to the top. How do you add fractions once you have a common denominator? You just add the top, you leave the bottom the same. So on the top here I have k squared plus 2k plus 1 over k plus 1 times k plus 2. This is still my p sub k plus 1. That still doesn't match what's up there, but we're getting closer. We at least have one fraction now. What could I do from here? Yeah, I think I could factor the top of this. Do you agree with that? And again, knowing what you're supposed to get is a hint there. That the top has like k plus 1 over k plus 2, which means we want to be able to cancel something out. What multiplies to give me 1, that adds to give me 2, plus 1, plus 1. So I get that term to work out to be k plus 1 over k plus 2. Kind of have a big mess up here, but every time I do these, I finish it by circling this and circling that answer up there and drawing a line up there to that other answer right here and checking it off that those equal each other. Again, once you do this step, you know what's supposed to happen. which is why this work is very important. On the test, I'm going to be very picky. One, make sure you know you're writing a proof and you write me all the steps. But two, don't just make up the work, because if you go from this step and then you write that it equals k plus 1 over k plus 2, okay, you know what you're supposed to do, but you didn't show me the proof. And that's what we're looking for there. So make sure you show me the algebra, show me the work in between there. But getting a common denominator, we should be able to do that. If you did not get the other ones done, I recommend going back. 1 and 4 aren't as bad as 15. Definitely no fractions involved. They're more similar to the first one that we did in our notes. I'm going to give you a few more problems today to do over the rest of 9-6, but definitely go back and look at those, because if you're not practicing them, you're not going to get better at them, because it's really easy to copy down what I write, but you got to make sure you can do that process. Okay? Okay. Let's finish up these notes. This is 9-6 day 2. This is our last day of notes. I kind of would like an extra day review in here, but I just don't feel comfortable not giving you 3 days to review for your final. So we really are going to review tomorrow and have our test on Wednesday. I would highly recommend, if you have some extra time, you could start reviewing now, start reviewing tonight, but we'll see. Your final here is the first day. So we'll have our test on Wednesday, and then we'll have Thursday, Friday, Monday, and then your final's the next day. So if you 5th hour isn't until Wednesday, and if we had that luxury in here also, I probably would spend an extra day reviewing, but I really don't want to only give you 2 days to review everything we've done. So the nice thing about today is it's not proofs. Because we've talked about proofs, and because we know that we can prove that things are always true, the last part of this is just giving you some formulas. And again, I'm going to let you write out the formulas for your test. But you're only going to be able to have formulas. You're not going to be able to write examples, right? Like, it's just going to be writing the formula, what it's called. You can even write what each letter represents. But you can't write, like, an example problem. But you're not going to have to memorize these, so that's the difference. And then we're going to show you how to use these. So here we go. And these are in your book. But we could do a proof by induction for every one of these, but we're not going to. But if you add up the first n integers, it will always add up to be n times n plus 1, all divided by 2. And if you look at that pattern for a while, you'll probably be able to figure that out. But we're just going to use this, and I'll show you how we can use summation notation to simplify these. And we're just going to do, there's like 5 of these. If you add up the first n integers squared, it get a little harder as you go along here. But again, I'm giving you the formula. You get n times n plus 1 times 2n plus 1 all over 6. And you might say, well, why wouldn't I just add them up? You could. But if I wanted you to add the first 50 integers by squaring them, this formula is going to be a lot quicker than you doing that on your calculator. And then I'll, again, show you some examples in a minute. Yes, so today's a better day. So that's why if you didn't get your proof by inductions done, hopefully you'll have some time. And hopefully maybe we'll have some time at the end that you can actually get started on this homework. Or ask me questions about previous homework. It's really not that terrible. It's very step by step. Like geometry proofs, you're just kind of like, here you go, try something. Remember all those theorems. Proof by induction, you do the same thing every time. So that's kind of nice. What about if we add up the first n integers by cubing them? is n squared times n plus 1 squared all over 4. And again, all of these we could prove by proof by induction, but they definitely would get a little ugly as you're cubing and squaring things with your k plus 1. We're going to go all the way to the 5th, and that's all I got.
Where are these coming from? Are these just, that's what they are?
These are just formulas that someone else has proved. Like, we could sit and look at the first, like, 5. Like, we could look at what are the first 5 sums and see if we could come up with these formulas ourselves. But they're just coming from someone else proved them, and we're going to use them later on. So we're just kind of skipping the proof part. Because these proofs get a little ugly. All right, this one's the craziest one.
What's wrong with your arms?
I don't think anything's wrong. Like sometimes your eye twitches. I don't know the answer to why it does it, but it's really okay. All right, so we have this one is n times n plus 1 times 2n plus 1 times 3n squared plus 3n minus 1 all divided by 30. How about the guy that came up with that one? He must have been pretty bored. You're right. You're probably right. Last one. And I'm sure there's a pattern for any integer added up like to any power, but we're just only going to the first 5 because, you know, you're probably tired of writing already. I don't think this one's as ugly as the 4th power, but it is long. N squared times n plus 1 squared times 2n squared plus 2n minus 1 all divided by 12. And again, on your test, you're going to be able to write those out. No requirement that you should be memorizing those.
Like, you're going to give us the sheet or like us write them out?
You're going to write them out. Like, you're going to, like, we'll talk about more tomorrow, but if you want to get a head start, it's one side only, handwritten, only formulas. Like, you just can't write examples to it. Like, you,
All the chapters.
the whole chapter 9, yes. And so that way, on Wednesday, you have a piece of paper that you've written that you get to use on the test.
If you want to, you can get organized with the paper and write out on the sheet.
I'm not. Let me know what definitions you're thinking about, all right? And then we'll talk about it. Well, I'm asking.
No, that one's not on the test. Yeah, you can have it. That's on the test. You can't do it.
I'm saying I don't know what she's talking about specifically, and so I'm asking her to let me know what she's talking about, and then I'll let you know. Okay? You're so grumpy all the time. You are. Like, you're always, like, hostile towards me. I don't know what's happened. He used to be such a nice guy. No, I feel like all year I've never had a nice conversation with you. We had to leave the game on Friday in the 3rd quarter because Parker was just done. I was kind of disappointed. It was an exciting game. I wanted to stay. Well, I asked Kinzer, and yeah, that you won, so that's good.
You didn't show up Saturday.
I didn't come Saturday. What?
You didn't write your Greek numbers right. You should go things going up and down.
Yeah.
Oh, well, I didn't write it. I typed it. It's fine.
Should have caught that mistake.
How are you? Sorry. This is saying add up the first 1 to 10 of n cubed. Going to 10 isn't that bad. You could just do 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 blah, 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 all the way to 10 cubed. That's not that bad to do. But I want to show you that you can also use the formula here. So when you see cubed, you're like, oh, I have a formula for n cubed that says I could just take n squared times n plus 1 squared all over 4, right? That's the formula that we just wrote out for n cubed. what number do you think you're going to plug in for n? 10. You plug in the top number. If this was 100 up here, using your calculator is not really the most efficient method, especially on a test that you only have 48 minutes to take. So this would definitely be where you would want to use the formula. And you just plug in that top number. So you're just going to take 10 squared times 10 plus 1 squared all over 4, and you're going to get your sum. Remember, we're squaring integers, so if you get a fraction or a decimal, probably you should have a problem with that because you're not having any fractions or decimals. I got 3,025. Did you get that? Yes? No? So they're not all going to just be a number to a power. They can throw other stuff in there because we can kind of simplify this and use our patterns, use our formulas, and use some other stuff. So let's look at one that's a little bit more complicated than this. Like this. I think she's at a high ability conference because Miss Bai's gone too. And her van was here this morning. Because I'm not on the high ability team. I don't know, because I'm not on it. There's just people from all the elementary schools and the high school that get together and talk about how to make our high ability kids more successful. And they look at all this data. Kids have to take tests every year. Like certain kids have to take this test that were marked high ability in elementary, and they like monitor their progress. I don't know, but it's ridiculous because once you get to high school, the kids that take it don't ever take it seriously. So then it always looks like you're just getting dumber. But mostly it's the kids who are like, does this test mean anything? No, I'd rather go back to class, so they just hurry through it. So. Yeah. And I think it's like elementary. So if you didn't go to elementary school here, even if you are high ability, you don't get to be marked high ability because they mark you in elementary school. Or if you didn't blossom as a high ability student until later on in life, you don't get chosen either. All right. Again, could we do this without any formulas? Yes. We could plug in 1 through 10 and add them up and get the right answer. But we can also break this apart. So with sums, again, sorry about the notation here. I guess I used the wrong font. I don't know. There you go. You can break these apart. You can also take the numbers out front. Because what we want to do is isolate the variable so we can use our formula. So let me kind of show you what we can do here. I'm going to break this part and rewrite this as the sum. Look at that one. J equals 1 to 10 of 3. We'll get there in a minute.
Oh, there's a square.
Minus, I'm going to take the coefficient in front. So I'm going to put minus 1/2, and then I'm going to put my sum. That was a little better. Of J. Because I can't use my formula for the first n terms if there's a half there, so I can kind of factor that 1/2 in front. That's what I'm trying to do here. And the same thing with this one, I can put a 1/2 in front from J equals 1 to 10, and then I can put J squared. Again, notice they're changing the letters on us. The letter that can be anything, N, J, K. Tucker asked last night what LOL meant. And I said, where did you hear that? He said, my dad said it, and my husband does not ever say LOL, so I'm a little confused where that came from, but whatever. Maybe he is some dad I don't know about. You think I would know? come back to this in a minute. This is our formula. What about this? What if I want to add up from 1 to 10 and I just have 3 there? Is it just going to be 3? The sum is going to be 3? Formula A, let's go back to this. That's if you add up the first n integers. So if you're counting like 1, 2, 3, 4, 5, 6. Is that what I'm doing if it just says a 3 there? What's the first term going to be? What's the second term going to be? What's the third term going to be? How many 3's are going to be there if I go from 1 to 10? 10 3's. So you can't just say it's 3, but what you can do is, we didn't write this formula out, but if you ever just have a number here and not a letter to go with it, can you always just take that number times how many times you would write it?
Yeah.
Always. So I'm going to say that's 3 times 10. Or 30. Keep this minus 1/2 here, because I got to work that out eventually. What about if it just has a letter? Which formula does that match with? Would that be the first formula? Would that be writing 1 through 10, 1, 2, 3, 4, 5, which you could just add up. I'm going to use my formula. This is formula A, and we'll write that up here. And I'm going to just actually write the formula, and then you can go back and plug in the numbers, but I'll write it so you know where this is coming from. So that's n times n plus 1 all over 2. Don't forget, I'm going to multiply that whole thing by 1/2 when I'm done. But you can kind of separate the number from the formula and just plug it all in. And what if I'm adding up 1 through 10 of j squared? Which formula is that? Formula B. And again, I'm just going to write that formula. If you want to go ahead and plug the numbers in, you can. But I always feel like in your notes, maybe it's a good idea to write where this stuff is coming from. And then you can just go and plug 10 in. Does that still take a little bit of work? Yes. Is it less work than actually working out 1 through 10? Definitely. I say show me at least what you're plugging in so I can see that you're doing the right thing in case you make an arithmetic mistake. And again, our top number here is 10, so I'm just going to plug 10 in for all these. So we want 10 times 11 over 2 plus 1/2 10 times 11 times 21 all over 6. And it's kind of up to you on how you simplify this. You definitely can just type this on your calculator. Just make sure you're careful. You could do each little one together and write the answer underneath and then do it all at once. Make sure you pay attention to your signs. That middle one is subtraction, so don't just automatically put an addition sign there. But it's really just using these formulas. I did each one separately, so in the middle, and I simplified it too, but in the middle I got minus 55 halves plus 385 halves, which turned out to be 195. Did you get that? Every year on the test, when I give questions like this, there are some people that just forget that you can have formulas, or maybe they didn't write their formulas on their paper, and you can get the right answer by just adding it up. But again, there's a limited amount of time, and so this would be the fastest way to do this problem. Questions about that general concept? I think I might be done. I don't know. I might be lying. I don't have any more room on paper, but sometimes I add extra examples in. Maybe one more. Oh my goodness, here we go. This is on your assignment sheet. I, for some reason, forgot to change it. Like last year, I had high hopes of doing that all in one day. What was I thinking? I know, right? But this day is definitely shorter. But this is day 2, which is not on your assignment sheet, so make sure you write that down. This is 9-6 day 2. And it is only 5 more problems, but it is not the same as your assignment sheet. 25, 28, 32, 33, 34. If you still have proof by induction that you haven't done, go back and start those first, since we actually have like 15 minutes to work, and you can ask me for help if you need it. Also, if you're missing a homework quiz, quite a few people from last week, it was over 9-4 and 9-5 day 1. You need to make that up. So if you want to do that right now, that's a great thing. Otherwise, see me soon. Yes. Because when you add that next term, you need to be doing this. Right? If you do 2K, this would be 2 times K plus 1, so we're going to change that to right? So you have to like, and so then, right, so then 4 times K plus 1, and it won't that's good. Where did you get a shirt like this?
Walmart, $9. Best $9 ever for money. There's a wolf, there's a tiger, eagle, a
Did you
bear.
buy one of these?
I'm gonna go back and buy the rest of them. I gotta buy the series.
Oh, okay, so they're just not writing it in summation notation, but they're wanting you to add up the first 5 numbers, right? So we're just going in order. 1, 2, 3, 4, 5, 6. So which one? The first one, and you're probably guys, on 25, they don't write it in summation notation. Okay, let's just kind of look at this real quick.
What?
I'll be right there, Logan. I just thought I'd help.
I need to come to you.
Right, they don't write it in summation notation, but can you figure out which formula you would use on this? The first one, and what would be your top number on your summation if you're writing it as a summation? 500. So you're going to just use that first formula, and you're going to plug 500 in. So you might have to think for a minute, like, is it... The nice thing, all of our formulas are either just in squared, in cubed, into the fourth. So you just want to look and see what the pattern is on those.